let's move on from the unit circle and start graphing trig functions. We're going to start with sine and cosine. We're also going to end with sine and cosine because of the circumstances. So we're not going to graph tangent or cotangent or secant or cosecant. We'll do that next year. So it's just sine and cosine. And we're going to start by filling out this table which goes with the unit circle. And then we're going to plot those points on our rectangular grid to see what they look like. So let's do the table. Sine is going to be first. We're going to do that in red. I'm just going to go around the unit circle and find the sine of these angles. 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2, and 2 pi. Remember, sine is the vertical part of the angle. So we're looking at how much that angle rises at these measures, how much the slope of that angle rises at these measures. But sine of 0, 0 degrees, is a flat angle. So it has no rise. It is 0. Pi over 6, 30 degrees, so it rises a little bit, but not a lot. It is 1/2. Pi over 4 is our diagonal measure. It is square root of 2 over 2. Pi over 3, 60 degrees, steeper but not quite vertical. This is the square root of 3 over 2. Pi over 2 is 90 degrees, so we're looking straight up. Pi over 2 is 1. Pi is 180 degrees, so straight to the left. It is 0, because although it is to the left, it has no vertical part. 3 pi over 2, 270 degrees, is going straight down on the unit circle, so that is -1. And 2 pi brings us all the way back to the beginning of the unit circle. It is 0. So those are going to be our coordinates for sine. And we're going to graph those in just a second. Now I'm going to go and do the same thing for cosine, filling in it. Remember, cosine is the horizontal part of the angle, though. It's the horizontal leg of that triangle on the unit circle. And so we want to keep that in mind as we go through these. But the cosine of 0, you can remember 0, horizontal. So the cosine of 0 is actually 1 because that angle is completely horizontal. It's pointing to the right. Cosine of pi over 6 is square root of 3 over 2. The cosine of pi over 4 is the square root of 2 over 2. The cosine of pi over 3 is 1/2. And that's because as we are going around, the amount of horizontal in the angle you can see is pulling back. That horizontal part is getting shorter and shorter as we go around. So we see the values decreasing until at pi over 2, which is a vertical angle, it is 0. At pi, now we're all the way to the left again, it's -1. At 3 pi over 2, straight down, 0, we have no horizontal. And then 2 pi, remember there are 2 pi radians in a circle, brings us right back to the beginning. So that's our table. Now we're going to plot them on our coordinate plane. And you'll notice that the coordinate plane looks a little different. The x-axis, now, instead of being 1, 2, 3, 4, 5, 6, is pi over 2, pi, 3 pi over 2, 2 pi, and these angles in between them are pi over 4. So on the x-axis, we are going to plot theta, our angle measure. And then our y-axis is where we're going to put the value of the sine and cosine graphs. And for that, It needs to go to +1 or -1 right now. So let's look at sine. Sine of 0 is 0. So this is like an ordered pair. X is 0, y is 0. That's the origin. And then we have these three angles. Pi over 6, 1/2, pi over 4, root 2 over 2, pi over 3, square root of 3 over 2. Those are special right angles, but they're not very easy to graph. The square root of 2 over 2, I can't approximate that very nicely on the graph. Square root of 3 over 2, I can't approximate that on the graph very well. 1/2 I can do, but pi over 6 is not an easy angle to graph down here. So we run into some issues with graphing those. So we're just going to ignore them unless we need them. I'm going to pick the values that are easiest to work with, which is a mathematical problem-solving technique. Instead of choosing values that are difficult to work with, assuming that we can recognize which values would be difficult to work with, we skip over them and begin working with the values easiest to graph, in this case the pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. And then if I absolutely have to get more detail on my curve, which we won't, then I would go back and start using these. But we're going to skip those. So I'm going to jump all the way to pi over 2, 1, kind of ignoring this side of that table. Pi over 2, 1, so I go to my pi over 2, go up on my y-axis to 1. Pi 0, put a point there. 3 pi over 2, -1. And 2 pi 0. And then I'm going to fit the curve to that. So we get this nice wave on the graph. In fact, that wave continues, which is why this is where I stopped. Once I got around the circle, that's as far as I needed to go, because I can now predict the rest of the behavior that I know from here. If I go to the right, it's just going to keep doing the same thing forever. And if I go to the left, it's going to repeat itself there as well. Because all we're really doing is spinning in a circle. The unit circle is our reference for sine, cosine, and tangent, and all the trig functions. So when we graph them, we end up seeing these repeated patterns. In this case, this wave form that continues forever. And we're going to see that exact same thing with cosine. It's going to look almost identical to sine, except for one important detail, and that's where it starts. Cosine, if we look at our table, did not start at 0, but rather started at 1. So at 0, cosine is at 1. And then again, root 3 over 2, root 2 over 2, 1/2, pi over 6, pi over 4, pi over 3, not the greatest angles to graph, so we're going to skip them for now. And if we look at this tail end of the table, we see really the same exact values for sine, the 0, the -1, the 0, and the 1, just kind of in different places. So pi over 2, 0, just like an x and y coordinate, x, y. Pi, -1, 3 pi over 2, 0, and then back to 2 pi at 1, and so we get really the same graph as sine. It's got that wave pattern, just shifted back a little bit. And if I go to the left, it repeats, and if I go to the right, it repeats. So that's what our graphs look like. for sine and cosine. And like any function, it's really just plotting points and seeing what the function looks like. So we did. We took our unit circle, we filled out the table, and then I just plotted those points. So getting the graph is not that bad. But we're not done there. We want to describe the graph. So that's what we're going to look at next. I want to look at a couple features of these graphs, really three, not a couple, three. But the amplitude, the period, and the midline of the graph. And then we want to see, well, if I have the graph, how do I figure out what these features are, what their value is? And if I have the equation, how do I figure out where these features would show up on the graph? So we're going to look at that now. Definitions. So here's what I mean when I say the amplitude, the period, and the midline. The amplitude. The amplitude is the distance the curve rises or falls from its midline. And in just a minute, I'm going to show you these. So this is just the definitions part of the notes. The period, the length on the x-axis for the curve's pattern to repeat one time. So we're looking to box in that repeated pattern. So those waves that we saw on sine and cosine. We're looking for what length would I have to go on the x-axis to box that in. So I have one repetition. And then the midline is a horizontal line bisecting, or cutting in half, the curve. So let's look at what these actually look like in terms of the equation and the graph. And we'll start with the graph, because we just saw that. But amplitude. Amplitude is the rise and fall of a pattern from its midline. And we can see here, the amplitude is this distance that we've got marked out in red. Notice it's going from the midline of the graph all the way to the highest point or lowest point. It's always positive, it's a distance. The period. Period is the length on the x-axis that the pattern repeats one time. And you can see that's exactly what we have here. The period, this red box, goes from the top of this wave, the top of this wave, and that's when that pattern would start to repeat. So if we were here, as I move to the right, that pattern's just repeating. If I move to the left, that pattern would be repeating. So we call that the period, or the period of repetition, if you want its full name. And it's just how long does it take until that graph starts to repeat itself. Then the midline. The midline is exactly what it sounds like. It's just a line that goes through the middle of the curve. So it bisects that curve. So those are the features we look for on the graphs of sine and cosine. In the equation, which looks like this, y equals a sine or cosine bx, and then plus or minus c. You'll notice those are just transformations. A is a vertical dilation or compression. It's stretching the graph or shrinking it. B is a horizontal compression or dilation, so it's stretching or compressing that graph. And C is a translation, so it's moving the graph up or down. And each one of those coefficients, A, B, and C, corresponds to one of these features, the amplitude, the period, or the midline. A, because it is a vertical dilation, goes with the amplitude. And in fact, the amplitude is just the absolute value of that leading coefficient A. Very easy, very nice. period is 2 pi, the number of radians in a circle, divided by b. Whatever b is, 2 pi divided by b gives me the period of that function. And the midline goes with c. And we get an equation. It's y equals c. Those are our features. And what I'm going to ask you to do is identify these features either from the graph or from the equation. So I'm going to do an example of that from the graph now, but we can do it from the equation as well. Let's go back to our desktop. Got to get rid of that, but you can look back earlier in the video to see it, and then our assignment here. So ignore the instructions. What we want to do is find the amplitude, the period, and the midline. So the amplitude, period, and the midline. For this one, I'm going to use the graph. So I'm not going to use the equation at all, just the graph to figure this out. First thing I got to do is figure out what is the midline, because the amplitude is based off the midline. I could do the period too, but I'm going to find the midline. The midline of this curve, oh look, well there's this at -2 is the bottom and 4 is the top. So I just need to find the middle of that, top plus bottom divided in half. So the midline here, 4 plus 2 divided by 2. 4 plus 2 is 6. Divided by 2 would be 3, which does not tell me the midline. It's not y equals 3, but it is the distance from top to bottom. So from the bottom, I go 1, 2, 3. From the top, 1, 2, 3. My midline would be at 1. So my midline here would be at y equals 1. Do it that way. 4 minus, oh, it's a negative, that's why. Anyway, but period. Or amplitude. Let's do amplitude next. Amplitude is the rise and fall of the graph from the midline, from that equilibrium. And here we can see the amplitude would be 3. So the amplitude is 3. And the period, our last measure, is how long it takes the graph to repeat. So I'm going to pick a point. Again, I want to pick the one that's easiest to work with, so I don't want to pick that point there, but rather probably one of these tops or bottoms. So I'm going to pick this one. And look, if I trace that, how long does it take for this graph to repeat itself? And it's going to be right there. That length is how far I have to go until the graph starts to repeat itself, which is from pi over 4 to 5 pi over 4. And so I would just subtract those. I would go 5 pi over 4 minus pi over 4, which is just 4 pi over 4 or pi. So the amplitude is 3, the period is pi, and the midline is y equals 1. For number 2, I'm going to use the equation. So I actually don't need the graph at all, but we'll leave it up there. So number 2, the amplitude is 3. Even though this is a cosine graph, the amplitude is just that leading coefficient, so in this case it is 3. The midline is that c value at the end. So in this case, the midline would be y equals 2. the period, we can add our parentheses here just to make it a little bit easier to read, but the period is going to use that 3. And unlike amplitude and midline, it's not direct from the equation. We do have to do a little bit of work. So I'm going to take the 3 to find the period, and it would be 2 pi divided by that coefficient on the inside, so 2 pi over 3, and that is the period of that graph, and that is how we are going to work with graphs of sine and cosine. And your assignments this week will focus on that. My plan is to have our first assessment on just this stuff, just the graphs, by Friday. So look forward to that.